Thank you very much for your introduction. I would like just to add just a few words about my institution. It's uranium research. It's the second biggest non-university based applied research institute in Austria. It's located in Graz. And we are rather multidisciplinary. We have 6 different institutes or departments. And my department is the resources department, which handles issues of water and energy resources. We have approximately 400 people there, and we're proud of this interdisciplinary research. But now coming to the project, what I represent today and what I would like to present today is the EU project INCREASE. INCREASE stands for increasing the penetration of renewable energy sources in the distribution grid by developing, first of all, control strategies and by using ancillary services. Control strategies is for better coordinating agents in the system, and using ancillary services is to find better remunerations for renewable energy sources. Just a quick overview about the agenda. I tell you something about the challenge, about our control strategies, what we are planning to develop and to test. A few words to our tasks and to the outcomes and about the consortium. You all know these 2020 targets. We have to increase, among others, also the share of renewable energy. If we talk about electricity, of course there are other technologies as well, but mainly it will be wind and photovoltaics. And we talk here especially about the distributed small-scale renewable energy sources. They will need to be significantly increased in the future. So that is very challenging, especially for the distributed system operators, DSOs, but also for the transmission system operators. The DSOs have to connect this distributed renewable energy sources by at the same time guaranteeing the power quality, what we have right now. They have to do it at rather low costs, and they have to do it now, not just in 10 years when the grid is ready for that. So the project INCREASE seeks for answers of how to actively manage renewable energy sources in the low voltage and medium voltage grid. For that we develop control strategies. And the second answer what we're looking for is how these distributed renewable energy sources, I call them DRESS, could participate in the ancillary service market in order that they get better remunerations for the energy, that they just not simply feed in energy into the grid, earn some money for that, but that they can provide system services where they can get out more money of it. This ancillary services is simply the voltage control and the voltage imbalance mitigation, the line congestion mitigation, and at the end the reserve and balance energy provision. That's the core of our research here. We have 3 different layers and 3 different options of intelligence of optimizing the system. At the bottom, you see here that we have different feeders in the grid, in the distribution grid. At each of these feeders, we have the consumers here, and steadily increasing, we have, for instance, photovoltaic panels on these houses. And in the summer, at sunny days in the midday, it could happen that you have violations of the power quality, so congestion or over voltages. And so right now, it's like that these PV installations have to go off the grid for a certain while in order to mitigate these PQ violations. Not in all the countries, these PV panel owners get full remunerations of their losses. They don't get balanced these losses. And of course, you don't have the maximum of renewable energy production, what you could produce if you have no grid restrictions. We at the project Increase develop a hardware where you don't have a 0-1 solution, where you don't have to get out of the grid for a certain while, but that you rather can steadily reduce your power injection as soon as PQ violations come up. This is, of course, the most unintelligent layer. It's simply for having a stable system, a stable grid system, by maximizing the power injection. Now the second layer above that is that we say, what about if these units here communicate with each other and bring up a better result by communicating? Of course, this has to be steered by somebody. We call this somebody overlying control agent of these distributed renewable energy sources. It could be made by, or could be done by the DSO. And this DSO simply, or this overlying control agent, simply tries to find an optimized system so that not only the last one in the grid is curtailed, but that we find a fair curtailment among this or within this feeder. This might cause losses in renewable energy, but it's a more fair approach, and we're going to calculate in this project what are the costs of this fairness. And of course, beside to PV installations which produce electricity, and we want to that they maximize the production, we have at the other side also demand response units, which could be the same at the same time like the producers. So the producers produce electricity, but because they're households or firms, they have loads, and they could probably shift the loads. These demand response units are also coordinated by an overlying control agent of the demand response units. And now comes the top of it. How can we act with the market, with the energy market and with the ancillary service market? Here comes the scheduling control agent into play, which tries to coordinate the market with the overlying control agents. How does that look like is what I present now, just in 2 slides. We have introduced 3 different kinds of traffic lights or traffic light system. We have these demand response units which have a certain schedule. As heard before and yesterday, they can either shift the loads a bit, sometimes they can't shift the loads, sometimes they have batteries and can even insert electricity to the system. Sometimes they just can reduce their energy demand, which is also a load shift. So they start with their schedule, and the scheduling control agent asks the coordinating agents whether we have a PQ violation, a power quality violation in the system. If we have no PQ violation, of course, the loads can do like they intended to do, and of course the PV installation produce like they can produce. If we have a PQ violation, the schedule of the demand response units is adapted a bit. Of course, they get money out of it. And how much they adapted and how much each of these demand response units is able to adapt is set by a cost curve for all the different demand response units. This is the simple traffic light. We have also a more advanced traffic light. Once again, we ask the question if a PQ violation exists, and if no PQ violation exists, okay, we can go on like we intended to do. And if there is a PQ violation, the question is made whether the demand response units help of mitigating this PQ violation. If yes, then they can do like they did, and if no, then they have to adapt their schedule as well. And the most intelligent traffic system is where we include PQ forecasts. So we have in 15 minutes advance PQ forecasts. How much will the sun shine? How much PV production will we have? How much loads do we have? And so based on this forecast, the demand response units can act already in advance. So this is a bit of flavor what I wanted to give you about how our basic thinking is in order to bring more remunerations for the distributed renewable energy sources and how they can participate in the ancillary markets. In the Increase project, we investigate, first of all, of course, the regulatory frameworks and the grid code structures and, of course, the ancillary market mechanisms, the existing ones. And based on that, and based on our simulations and calculations, we propose adjustments in order that distributed renewable energy sources and demand response units can provide ancillary services to the market, and how the DSOs, the distributed system operators, can evolve from a reactive congestion manager to a proactive capacity manager. We also provide a simulation platform in this project where we first of all validate our simulation results, of course, and we provide a tool for the DSOs to investigate the DRESS influence on their grid systems. What are the results? As I mentioned before, we are developing a hardware, a three-phase four-wire inverter for the lowest level of these control strategies. This will be also implemented by the distribution system operators. So they are happy to test this. The other results, like a multi-service and multi-objective distribution control system, the ICT system, which is also used in the field trials, and the control strategies are done on a desktop and on a simulation tool. And we have also lab scale and real-life validation, as I mentioned before. And of course, at the end, we have this validation of the market and regulatory framework, and wherever possible and wherever it makes sense, we propose improvements for that. Just some words to the consortium. We represent 5 countries in the EU, and it's very important for me to mention that we have also, apart from industrial partners which invent the hardware systems, we have also for distribution system operators in our consortium. They make a kind of reality check whether they could implement what we are researching on. And as I said, they are going to implement this hardware and test it for their purposes. Just for your information, which institutions are in this consortium, we are institutions in Austria, Belgium, Greece, Slovenia, and the Netherlands, research partners, industrial partners, and, as I said, DSOs. Yes, I thank you for your attention. I think I'm perfectly in time, and I'm happy for questions and discussions.